Hello everyone, here is my second lecture on Introduction to Quantum Mechanics, in which we will discuss about the phase velocity and the concept behind to obtain a wave packet of group velocity will also be discussed. Again, I kind of feel to ignore the alignments of text. Let us know the concept behind to obtain a wave packet. First of all, as we know that the phase velocity means, in the previous lecture we have discussed about the de Broglie's concept. According to him, with each matter particle, a wave is associated which is known as a matter wave. The velocity of that wave is known as phase velocity. In other words, the velocity of a single wave is known as phase velocity. According to de Broglie, we got that lambda, which is the wavelength of that wave associated with a matter particle, is expressed by h upon p. P represents the momentum, it is equal to mv. H represents to the Planck's constant, and these are the basic terms, mass and velocity of particle. So here this equation represents the duality nature. This on left side represents to the wave nature, right side represents to the particle nature. Now, by taking it a wave nature, we know that if a matter wave is associated, okay, then energy is expressed by equal to h nu, where h Planck's constant and nu be the frequency, which can be obtained with the help of this equation as h upon e upon h. This equation represents the wave nature. Again, we know that according to Einstein's mass energy relation, we have equal to mc square. This, by substituting this value of energy in this equation, we obtain frequency in this manner. Okay. Now, to obtain the velocity of de Broglie wave associated with a particle, okay, here that velocity is represented by v, de Broglie wave's velocity. Wave velocity means it will be equal to that wave frequency and the wavelength. So here this frequency is substituted from here, and this wavelength is substituted from here, h upon m will be cancelled, h will be cancelled, we have c square upon v. Here c with the speed of light and v with the speed of matter particle. We know that the matter particle's velocity is much less than the speed of light. It is found in non-relativistic case, where the relativistic effect is not studied. When v is comparable to c, then the effect is known as relativistic effect. So we don't have to discuss that one. We have to consider non-relativistic effect. So v less than c, in other words, u will be greater than v. Now we have to see, by considering the wave nature, by substituting the properties of wave, we obtain a relation where it represents the nature of wave, it represents the nature of particle. So this is the parameter belonging to a wave. This parameter belongs to the particle nature. Wave u, velocity of de Broglie wave, v, velocity of the matter particle. So matter particle's velocity less than c. This value smaller than u. So velocity of wave associated with a matter of velocity is v, and it is greater than v. So wave velocity is higher than particle velocity. In other words, particle remains back and wave moves forward or ahead. But according to the de Broglie concept, wave must be always associated with a matter particle. But here we are finding that wave is moving ahead and particle is just remaining behind. So finally, it is concluded that a single wave is not associated with a moving matter particle. Instead, many waves are associated with that particle. Few waves can move ahead, few will be associated with that one, and few remain back. By the superposition of all those waves, we have a group, a wave packet, means a group of waves. In other words, that is known as a wave packet. And that resultant wave packet's velocity is known as group velocity. So here, with the help of this relation, we obtain a concept to obtain a wave packet. So I think it has been clear. Now we will derive the equations belonging to phase velocity and afterwards group velocity. As we already been discussed, phase velocity means velocity of wave associated with the particle. So let a wave which is propagating towards the x direction, which is expressed by y equal to exponential I imaginary term kx minus omega t, where y represents to the displacement, k represents the propagation constant of a wave, which is equal to 2 pi upon lambda. K represents to the displacement, omega angular frequency, 2 pi nu, nu with the frequency here, and t with the time. Here, this whole term, the power of this one, or exponential of this one, exponential is taken of that one. This term is known as phase, kx minus omega t. If wave propagates, if it is coherent wave means its frequency and wavelength as well as the amplitude remains constant, then this phase is also be constant. How? Phase means this term. By talking about this point A, let a particle is located at point A, then the physical parameters belonging to this particle at this position is known as phase of this particle at this position. Similarly, phase of this particle at this position is called, okay, that represents the phase of this one, okay. Individual points and phases are shown for respective particles. So if wave propagates, then these particles will also be propagate along with wave. Because of that, these particles will remain at their positions. There is no change in their positions. A remains at top, B remains at node, C remains as well as an antinode. Okay, there will be no change. Means the parameters belonging to this point, okay, will always be constant. Means there is no change. So means this term represents the phase of this point, point A will be constant, as well as it is equally applicable for point B, point C, point D, and so on. So by taking that concept, this one is constant, we obtain x constant, and this one will be plus omega t upon k will be divided by here, and by differentiating with respect to t, we have dx upon dt, constant will be 0, and omega upon k is kept outside and t is differentiated. Since omega means frequency is constant, means omega will also be constant, and k lambda means k will also be constant. So t is a variable since time is varying, so it will be 1. So we have omega upon k by differentiating with t. Then we have dx upon dt equal to omega by k. This term represents the velocity, and we already know that single wave velocity is known as wave velocity or phase velocity, omega by k. Again, by substituting the values of omega, 2 pi nu, k, 2 pi upon lambda, we have nu lambda. Here 2 pi will be cancelled and lambda will be shifted to the numerator. Finally, nu lambda. So phase velocity equal to omega by k or nu lambda. These both equations will be used according to the need of. So next, to derive the group velocity, since we have been discussed that the velocity of a wave packet is called group velocity, and the wave packet is obtained by the superposition of many waves. So here we considered two waves. By the superposition of them, we have a wave packet, and the velocity of that packet is called a group velocity. And the velocity of individual, those superposing waves, is known as phase velocity. So phase velocity may differ for different waves, but group velocity will be individual value, since that is obtained due to superposition of those waves. Okay, here two waves are taken. First one's frequency equal to 2 pi nu 1, second one's 2 pi nu 2. Their wavelengths are lambda 1 and lambda 2. Propagation constant are expressed by, and the wave equation of them are expressed by y equal to a sin omega 1t minus kx1. In this manner is also expressed a wave function, as well as y2 equal to a sin omega 2t minus k2x. A represents to the maximum amplitude. It remains always constant, the factor of sine. This concept will be utilized in the final stage of this derivation. So these are representing to the displacement equations of individual waves. So after superposition, we have the resultant displacement equal to the sum of the displacements of respective waves, substituting the values, and we know that this is the first term is trigonometric function of sine, and second one is also belongs to sine. So sine, if this is the whole, this phase is considered as capital A and this one as capital B, then we have, by taking comma a, small a outside, we have sine A plus sine B. Okay, if it is considered as capital A and capital B, sine A plus B. So sine A plus B equal to sine A plus B by 2 multiplied by cos A minus B by 2. So here same equation is applied. A is kept outside, small a, 2 sine A plus B by 2. So means when these are added, then first terms will be added, divided by 2, t kept it outside, minus is kept out, and the summation sum is taken of k1 and k2, and x is kept outside. As a factor, cos a minus b by 2 is taken here. A means this one, b means this one. A minus b means omega 1 minus omega 2 by 2, b kept outside, minus is taken here, and then k1, k2 are subtracted. So here the cos term is kept in front of as a factor of sine. 2 rays remain same. Again, we consider that the difference between these two angular frequencies is equal to delta omega, and this difference equal to delta k, and mean of these two values is equal to omega, and these values equal to k. See, omega and the mean of propagation constants is taken equal to k. By substituting these values, difference values and the average values in this equation, We will have 2a cos delta omega by 2t delta k by 2 sine omega t minus kx. See, kx. That is written here. On the left side, we will have y. Here, y. So, it represents to a resultant displacement equation. That means it is a wave equation of a wave packet. This figure represents the wave packet, which is obtained due to superposition of these individual progressive waves. See, the first wave and second of displacement equations are taken like by superposition of them. We have this wave of velocity is known as group velocity and is called wave packet. So this equation represents to this one, wave packet. Here, this term, factor of sine, represents to a resultant amplitude, which remains constant. If this remains constant, means this the term within a bracket will also be constant. Okay, so it is kept at constant. Let's see next. Before that one, here two figures are included for knowledge purpose. These the peak of this one is known as antinode, which is located above the propagation line, and the below one is known antinode also. These 2 points are known as nodes. The above point antinode is also known as crust, and the below antinode, below means below to the axis of propagation, this antinode is known as trough. Somewhere while discussion talking about the wave nature, these key points will be utilized. So here we found that due to being constant of this one, this will also be constant, and delta omega and delta k representing to the difference values. Okay, difference values. So by differentiating this one, we will have, with respect to t, we have this equation, dx upon dt. Okay, here t will be 1 minus delta k by 2 is kept out, and dx upon dt will be obtained here, and this term, when differentiated with respect to t, we have delta omega by 2. T becomes 1. This term remained outside, and as a factor we will have dx upon dt. So after simplification, we have this equation, dx upon dt equal to this one. It represents the group velocity, the velocity of wave packet. And by applying the limit, when omega 1 tends to move towards W2, means both the angular frequencies, when try to equalate, then this term will be equal to d omega upon dk. So Vg will be equal to d omega upon dk. Next, we will see what is the relation between Vp and Vc. As we already been seen that Vp equal to omega by k, or in terms of omega, which will be equal to kvp. See, and Vg we obtained equal to d omega upon dk. So by substituting the values of this one at this place, we have d upon dk and kvp. By differentiating this one, we have by when Vp is kept outside and differentiating to k, so it will becomes 1, which is shown at the first term, plus k. Now k is kept out and Vp is differentiated here, so we have this one. Again, we know that k is a propagation constant. By substituting the value of k here and here, 2 by 2p will be cancelled, and we have plus 1 by lambda will be here, and dVp upon d 1 by lambda. d 1 by lambda, when it is differentiated, we have minus lambda power minus 2. See, 2 pi will be cancelled. So we have dVp upon d 1 by lambda. So lambda is a variable, therefore it is needed to be differentiated here. So it is called partial differentiation. Then d 1 by lambda will be equal to minus lambda power minus 2. Lambda power minus 2 means here minus lambda power minus 2. So lambda square will move to the place of numerator, and here will be minus. Plus minus will be minus, and lambda square will be here. Square will be cancelled with lambda. So we will have minus lambda dVp upon d lambda. So this is the relation between Vg and Vp. In other words, group velocity depends on phase velocity. Okay, and the phase velocity is also varied with respect to wavelength. Let's see what will be the relation between Vg and Vp in different medium. Two cases are taken here. Talking about the non-dispersive medium. Non-dispersive means the velocity of all waves, okay, will be equal. So velocity is equal means the velocity of group wave packet. After superposition of them, that will also be equal to Vp, the velocity of individual waves. So here we obtain Vg equal to Vp. But in terms of how, okay, in terms of the concept, both will be equal. But by following this one, we obtain that in non-dispersive medium, this term, since the Vp of all velocities, all waves, okay, Vp is equal. Means this remains doesn't depend on the wavelength. Even being different wavelengths, their velocities may be equal. So this term will be 0, then V is equal to 2. That is called, that kind of medium is known as non-dispersive medium. And in this medium, these terms will be equal. It can be understood as when electromagnetic waves are in vacuum or elastic waves in a homogeneous medium, then even having a wave packet, the velocity of that packet will be equal to the velocity of individual waves. Now just opposite in the dispersive medium, when the velocity of individual waves will differ, that means this term will not be equal to 0. So it may be positive or negative. If it is positive, see, if it is positive, then Vg will be less than Vp. If it is negative, so negative will be plus positive, and as a resultant Vg will be greater than Vp. When it is negative, let's see. When it is negative, then Vg will be greater than Vp. It occurs when when waves are propagated in electric conductors, then the group velocity will be greater than the wave velocity. When it is positive, then Vg will be less than Vp. Vg will be less than Vp. It occurs when electromagnetic waves are propagated in dielectric medium. So, depending on the medium, the velocity of different velocities may be equal or may differ. If they are equal, in this case, this type of situation is obtained. If they differ, then maybe Vg may be less than Vp or greater than Vp, and it will be positive or negative. It depends on the medium. we will try to find the phase velocity and group velocity for a non-relativistic particle. As we have seen that energy of a particle which is in motion with velocity v is expressed by this equation, equal to v square upon 2m. Since E equal to half mv square, it represents the kinetic energy. As we know, by multiplying m, the numerator, and in the denominator, then we have m square v square. M square v square means p square. And here as a factor, we have 1 by 2m. See, 1 by 2m and p square. So kinetic energy is transformed in terms of momentum in this manner. So energy of a matter particle or any usual particle is expressed by this equation. Now it will be transformed in other form by using the de Broglie's concept. According to de Broglie, we know that lambda equal to h upon p. So p equal to h upon lambda. This value will be substituted here. H upon lambda. It will be h square 2 upon 2m lambda square, and lambda equal to, with the help of this equation, lambda will be equal to 2 pi upon k. By substituting here 2 pi upon k, lambda square means k square will be here. 2 pi square means 4 pi square. 4 multiplying with 2, we have 8 pi square m in this equation. Again, by considering the wave concept, the energy of the particle or wave associated with the particle is expressed by E equal to h nu equal to omega upon 2 pi. Okay. Here E also represents to the same particle. So by equating these two parameters, we have this relation or omega equal to this equation, h square will be cancelled with h, pi cancelled with square, 2 cancelled with 8 means 4. So here will be 4 pi m, here will be h cancelled, so h k square. So by considering the duality nature, we obtain the angular frequency in terms of propagation. Why? Since we know that Vp is a function of omega, Vg is also a function of omega. If we have omega, then with the help of this one, we can easily determine Vp and Vg. So by substituting this value here, omega upon k is kept here. We have k square will be cancelled by k, hk upon 2 pi m. K means 2 pi upon lambda, 2 pi upon lambda, 2 pi. So it will be cancelled. Here remained 2 h 2 m lambda, and h upon lambda equal to p. According to this concept, p equal to mv, mm will be cancelled, v by 2. So for a non-relativistic particle, phase velocity will be equal to half of its velocity. Similarly, by deriving Vg, again by substituting the values omega here, see, means there is need to differentiate related to k. So if we differentiate with respect to k, so here h upon 4 pi m are constants, so kept outside, and differentiating to k square, we have 2k. 2k means, see here, 2 will be here 2 hk 4 pi m, and hk will be here 2 will be here. Okay. Again, k equal to 2 pi upon lambda, 2 pi will be cancelled, and lambda will be here h upon m lambda. Again h upon lambda, lambda equal to h upon p. P means mv. Okay. H will be cancelled, will be cancelled, v came to the numerator, and in other words, Vg is equal to Vp. Means for a non-relativistic particle, group velocity is equal to the velocity of itself. Okay. For a non-relativistic particle, wave velocity equal to half of itself velocity. That group velocity will be equal to velocity of an individual. So that's all in this topic. So in this lecture we have discussed about the concept behind the wave packet by discussing about the phase velocity and peak velocity. Their equations are also obtained. The relation is built, and on the basis of that one, different mediums are discussed, and as well as their values are also found for a free particle, which is in a relativistic motion. I hope you have been understood about Vp and Vc.